Hello students, this is Nikilian, Assistant Professor, Department of Civil Engineering, IIT Mangaluru. So in my previous session, I had discussed about waterborne macadam pavement. So there, in waterborne macadam pavement, I had discussed about what are the materials used in the construction of WBM pavement and what should be the specification of a material that is used in the construction and what are the construction processes or what are the construction steps used for constructing the pavement. So today in this section I am going to discuss about wet mixed macadam pavement and crusher run macadam. So first let us consider wet mixed macadam. So what is the difference between wet mix macadam and waterborne macadam pavement? So in waterborne macadam pavement, the pavement is constructed without using water, or the pavement is constructed with minimum use of water. Whereas in wet mix macadam pavement, the pavement is constructed using water. Hence, the name is wet mix macadam. Here, the mix which is used for the construction of pavement is made wet using water. So first let us see what is the scope of wet mix macadam. This work shall consist of laying and compacting clean crust graded aggregates and granular material premixed with water to a dense mass on prepared subgrade or subbase or base or existing pavement, as the case may be in accordance with the requirement of this specification. The material shall be laid in one or more layers as necessary to lines, grades and cross sections shown on the approved drawings or as directed by the engineers. So the wet mix macadam pavement consists of materials like crust stones, graded aggregates and granular material which are compacted by mixing the material with water. Hence water is added, hence the mix will be of dense mass. So the prepared mix is laid on the subgrade or it is laid on the base or on the existing pavement. So the layer below the wet mix macadam depends upon the specification and requirement of the project. So here the materials will be laid in one or more layers depending upon the importance of the project or as it is specified in the drawing or directed by the engineer. The thickness of a single compacted wet mix macadam layer shall not be less than 75 mm. So the wet mix macadam pavement can be laid in one or more layers. When the wet mix macadam is laid for only one layer, then the pavement thickness should not be less than 75 mm, and the maximum thickness of single layer pavement should be up can be up to 250 millimeter. So next coming to the materials. So what are all the materials used in the construction of wet mix macadam? So firstly aggregates. So aggregates is a material which is used in the construction of wet mix macadam as well as in waterborne macadam. So what are the physical requirements of the aggregate when it is used in construction of wet mix macadam? So the physical requirements: coarse aggregates shall be crushed stone if crushed gravels single is used, not less than 90% by weight of the gravel or single piece retained on 4.75 mm sieve shall have at least two fractured faces. The constituents of the aggregates shall be produced by integrated crushing and screening plant, and unless otherwise instructed by the engineer, crushing stone shall be carried out in at least two stages. The fraction of material passing through 4.75 mm sieve shall also be crushed, run screening only, and the aggregate shall conform to the physical requirement set forth in table 412 of Morth or Indian Road Congress 109 in clause 3.11. If the water absorption value of the aggregates is greater than 2%, we should conduct a soundness test for the material. So there are some parameters which is specified in IS 2386 part 4. So the aggregates which are used in the construction of wet mix macadam pavement should have a abrasion value less than 40%. So the maximum value can be 40%. So if the abrasion value is less than 40%, it is well and good, and the aggregate can be effectively used in the construction of wet mix macadam pavement. Or if the abrasion value is not considered, we can check the impact value of the aggregates. The impact value of the coarse aggregates as per IS 2386 part 4 should be less than 30%, or it should be maximum of 30%. So the aggregates with impact value more than 30% are not suitable for use in the construction of wet mix macadam. And secondly, coming to the shape of aggregate. If the shape of aggregate is very flaky or if it is very elongated, then we can't use the aggregates in the construction. So this is specified in IS 2386 part 1. So the flakiness index and elongation index of an aggregate should be less than 30% or maximum of 30%. If flakiness index and elongation index is more than 30%, then the material is not suitable for the use of using pavement, because with increase in flakiness and elongation, the edges of the aggregate will become sharp and it will become very thin. So as a result of this, when this flaky or elongated aggregates subjected to loading from the vehicle, the edges of the aggregates will undergo breaking. So once the aggregate breaks means it is termed as a failure of a aggregate. If the water absorption value of the coarse aggregate is greater than 2%, then the soundness test shall be carried out on the material delivered to the site. So water absorption. If the aggregates used in the construction of wet mix macadam absorbs water more than 2%, then we should conduct soundness test. So in my previous session, I had discussed how to conduct a water absorption test of aggregate and how to conduct soundness test of an aggregate while discussing about waterborne macadam pavement. So same procedure is used for the aggregates in case of wet mix macadam. So grading requirements. The aggregates used in the construction shall conform to the grading level or should conform to the grading limit given in the table. So this is a table which is given in IRC 109 2015. So the materials or aggregates used in the construction should conform to this specification. So here it is given IS sieve of 53 mm. When the material is sieved through this IS sieve of 53 mm, the percentage by weight passing the sieve should be 100%. Similarly, when the material is sieved through 45 mm, then the percentage should be 95 to 100%. So it is percentage by weight passing through the sieve. So this is the specification which should be followed in the selection of materials in the construction of wet mix macadam. And the materials finer than 425 micron shall have a plastic index less than 6. The final gradation approved within these limits shall be well graded from coarse to fine and shall not vary from low limit on one sieve to high limit of the adjacent sieve or vice versa. So if the materials satisfies this condition, we can use the materials in the construction. So next, let us see what is the construction operation or what are the stages in construction of wet mix macadam. So before the work begins, we need some of the equipments to be set in the field. So the equipments which are required in the construction of wet mix macadam are wet mix macadam plant, tippers or dumpers, rollers, water tanks, paver capable of paving more than 9-meter width, and survey kit or survey instruments. So these are all the equipments which are required in the construction of wet mix macadam. Now let us see what are the different stages in the construction of wet mix macadam. So the first stage or the first step in the construction is preparation of base. The surface of subgrade, subbase or base to receive the waterborne macadam cores shall be prepared to the specified lines and crossfall, arid made free of dust and other extraneous material. So subgrade, subbase or the base. So this is the layer which receives wet mix macadam pavement. So the layer which is beneath the wet mix macadam pavement should be prepared first. So if there is any grasses or if there is any waste materials on base, subbase or subgrade, so that should be removed first. The surface should be made even by considering the camber, and if there is any unevenness in the base or subbase, it should be made proper, and then the wet mix macadam layer is laid. So this is how the preparation of base is done. So if it is required, water is sprinkled on the subbase, base or a subgrade, and the layer after sprinkling with minimum quantity of water, it can be rolled with a roller with one or two passes if it is required. So the second process or second stage in the construction of WEMM pavement is provision of lateral confinement of aggregates. While constructing wet mix macadam, arrangement shall be made for the lateral confinement of wet mix. This shall be done by laying material in adjoining shoulders along with that of wet mix macadam layer. So after preparation of base, then the wet mix macadam is laid. So here before laying a wet mix macadam, we should provide a lateral confinement of for the wet mix. So lateral confinement is nothing but we should provide a lateral support for the wet mix. So we are providing lateral support or lateral confinement for the wet mix to avoid the running out of wet mix from the pavement surface. So this can be done by laying materials in adjoining shoulders along with that of wet mix macadam layer. And here the main advantage of constructing lateral confinement is that the road surface to be constructed retained in between them, and it becomes easy to further laying of coarse aggregate. Hence, we should provide lateral confinement of aggregates in the construction. So the third process or third stage in the construction is preparation of mix. Wet mix macadam shall be prepared in an approved mixing plant of suitable capacity, having provision for controlled addition of water and forced positive mixing arrangements like pug mills or pan type mixer of concrete batching plant. So the mixing of the mix or preparation of the mix should be done in a mixing plant, and the mixing plant should have a suitable capacity to accommodate the requirement of a pavement. And here the mix is prepared by controlled addition of water and by forced or positive mixing arrangements like pug mills. And here the optimum moisture for mixing shall be determined in accordance with IS 2720 Part 8. So after replacing the aggregate fraction retained on 22.4 mm sieve with materials of passing from 22.4 and retained on 4.75 mm, while adding water, evaporation loss shall also be taken into account, and the mixed materials should be uniformly wet and no segregation shall be permitted. So after preparation of mix, the next stage or the next process is spreading of mix. So immediately after mixing, the aggregates shall be spread uniformly and evenly upon the prepared subgrade, subbase or base in required quantities. The mix may be spread either by pair finisher or motor grader. For portions where mechanical means can be used, manual means as approved by the engineers shall be used. So spreading of the mix is the fourth stage or the fourth process. So here, immediately after mixing, the aggregates are brought to the site and the aggregates are spread uniformly and evenly upon the approved subbase layer. The material should neither be dumped in heap nor there falling over a partly completed stretch. The first layer will be laid by motor grader, and the second layer of the mix shall be spread by a WMM paver finish capable of paving minimum of 4.5 meter to 9 meter width, and the layer may be tested by depth block during the construction, and no segregation of materials are allowed. The aggregates should be of uniform gradation with no pockets of fine materials. And if mechanical means is not possible for the spreading of aggregates or for the spreading of mix, then we can spread the mix uniformly using manual power, but this should be approved by the engineer. So after spreading of the mix uniformly over subbase or subgrade, the next stage is compaction of the mix which is spread on the previous layer. So after the mix has been laid to the required thickness, grade and cross fall or camber, the same shall be uniformly compacted to full depth with suitable roller. If the thickness of single compacted layer does not exceed 100 mm, smooth roller of 80 to 100 kN weight may be used. For the compacted single layer up to 200 mm, the compaction shall be done with the help of vibratory roller of minimum static weight of 80 to 100 kN or equivalent capacity roller. The speed of the roller shall not exceed 5 km per hour. So here in this process, the mix is compacted uniformly to its full depth by using a suitable roller. Suppose if the pavement is having a single layer and the thickness of layer does not exceed 100 mm, then we should use a smooth wheel roller of weight 80 to 100 kilonewton. Suppose if the layer thickness is up to 200 millimeter, it is more than 100 millimeter and less than 200 millimeter, the compaction should be done by using vibratory roller or with a other roller which is having the equivalent weight of 80 to 100 kilonewton. And here it should be noted the speed of roller should not exceed 5 km per hour. So each pass of the roller shall be uniformly overlapped and the grade and crossfall shall be checked and any eye spot or depression which become apparent should be corrected and the speed of the roller should be within 5 km per hour and the rolling shall be continued till density of the layer is achieved 98% of the maximum dry density and the roller should not be done with water with wet mix macadam layer is soft or yielding or when it causes a wave like motion if the level difference or irregularities developed during the rolling which exceeds 12 mm when tested with 3 meter straight edges, the surface should be loosened and pre-mixed material added or removed as required before rolling again. In no cases the unmixed material be permitted to take up the depressions. Yes, the next process after compaction is setting and drying. After final compaction of wet mix macadam coarse, the road shall be allowed to dry for 24 hours. So once the wet mix macadam is being compacted, then the road should be allowed for drying and setting for a time duration of 24 hours. Then opening to traffic. Preferably, no vehicular traffic of any kind should be allowed on finished wet mix macadam surface till it has dried and the wearing course is laid. So after testing the compaction and level of wet mix macadam, the road should be allowed for drying for 24 hours. So during this time, no vehicular traffic should be allowed on the road. So the vehicles are allowed only after completion of the road. So the road will be finally completed after laying of wearing course. So before laying of wearing course, we should check the strength of a pavement and we should check whether the wet mix macadam surface is completely dried and if there is any undulations or if there is any irregularities, all these things has to be rectified and it has to be corrected. So after making all the necessary work, the vehicles are allowed on the road for the movement. And the next process is surface finish and quality control of work. The surface finish of construction shall conform to the requirement of clause 902. Control on the quality of materials and working shall be exercised by an engineer in accordance with section 900. The surface finish of the pavement should conform to clause 902 of MORTH specification. And here the control of quality of materials should conform or it should be accordance with section 900 or table 400 of IRC. So here for example if I consider the gradation should be conformed with respect to IS 2386 part 1. So the material gradation should be as specified in IS 2386 part 1 and if I consider the flakiness and elongation index The flakiness and elongation index of a material should be within 40% or within 30% as mentioned in IS 2720 part 8. So if the materials specify this limits, or if the materials which are used in the construction are conformed with these limits, then the quality of the work as well as the quality of the material will be good. Then arrangement for traffic is the next stage. So I had already told you, when we go for the construction of a new pavement, we should construct the pavement in such a way that there should not be any interruption for the flow of traffic during the construction. So for the movement of a vehicle, we should make the arrangement. So during the period of construction, the arrangement of traffic shall be done as per clause 112. So in the clause 112 of MORTH, it, it is specified that alternative ways should be provided for the movement of traffic. So here what happens is, normally when we go for the construction of new pavements, there will be a disturbance for the flow of traffic. So this has to be avoided. So for this we should construct a diversion, and we should divert the vehicles which is coming on the road or which is constructed, or we should provide a sufficient space on the same carriageway for the movement of vehicle, or we should provide a alternative carriageway for the movement of vehicle which is near to the highway. So the final stage or final process is measurements for pavement. So waterborne macadam shall, shall be measured as finished work in the position in cubic meter. So the waterborne macadam is measured in terms of cubic meter. So similarly, we measure the work done in wet mix macadam in terms of cubic meter. So here the measurement for the pavement in case of waterborne macadam as well as wet mix macadam is the same. So in both the constructions it is measured in terms of cubic meter. The next type of granular pavement is crusher run macadam. It is also called as CRM. So now let us see what is this crusher run macadam, what are the stages in the construction of crusher run macadam, and what are the materials used in the crusher run macadam. So what is the scope for CRM? This work shall consist of furnishing, placing and compacting crushed stone aggregates, subbase and base course constructed in accordance with the requirements set forth in this specification and in conformity with the lines, grades, thickness and cross sections shown on the plans or as directed by the engineers. So here the base or sub-base course is constructed as per the requirement for the project, or this base or sub-base is constructed as per the specification given in the contract. So the construction of base and sub-base involves a proper designing of a camber and proper designing of a slope and thickness. So all this are done by specification which is given in the contract, or the construction is followed as per the instruction of an engineer. So after doing all this, the crushed stone aggregates are furnished, placed and compacted over this already prepared base or sub-base courses. So what are all the materials used in the construction of crusher run macadam pavement? The material to be used for the work shall be crushed rock. If crushed gravels or shingle is used, not less than 90% by weight of the gravel or shingle piece retained on 4.75 mm sieve shall have at least two fractured faces. The aggregates or the materials used in the construction work of crusher and macadam. Here, the material should not be less than 90% by the weight of gravels and should not retain on 4.75 mm sieve. So here is a table which specifies the requirement for a material. So here we have sieve size 53 mm maximum size and 35.7 mm maximum size, percentage passing by weight. So the percentage passing by weight through 63 mm sieve should be 100% for 53 mm size, and for 37.5 mm size there is no specification, and percentage passing by weight of aggregate through 45 mm sieve is between 85 to 100% for 53 mm maximum size, and for 37.5 mm maximum size 100% is the percentage passing by weight. Similarly, for 22.4 mm sieve and 5.6 millimeter sieve, 710 micron and 90 micron. Here in this table it is given what should be the percentage passing by weight. If the water absorption value of coarse aggregate is greater than 2%, the soundness test shall be carried out on the material delivered to the site. So here also it is same as previous two cases. So the maximum water absorption capacity of an aggregate should be below 2%. If the water absorption capacity of the coarse aggregate is more than 2%, then we should go for a soundness test. So here in this slide, you can see a table. In this table, we can see what are the limits for different parameters of a coarse aggregate. So the abrasion value of the coarse aggregate should be within 40%, or 40% is the maximum abrasion value of the coarse aggregate that is used in the construction of crusher run macadam, and this is specified in IS 2386 part 4. And similarly, the maximum impact value of the aggregate should be 30%. So it should not be more than 30%. If the impact value is more than 30%, then it suggests that the material is not strong, or it is not tough. So the combined flakiness and elongation index, as per IS 2386 part 1, the maximum percentage is 30. So it should not exceed 30%. If it exceeds 30%, the material will be more slender, and when it is subjected for loading, the edges of the material will undergo breaking. The water absorption capacity of the material, as per IS 2386 part 3, is maximum is 2%. It should not absorb water more than 2% of its weight. Then liquid limit of material passing through 425 mm is maximum of 25%. It should not be more than 25%, or it should be maximum of 25%, and this is specified in IS 2720 part 5. And plasticity index of the material passing through 425 micron. So the plasticity index of the material should not be more than 6%, or the maximum plasticity of the material which is passing through a sieve of 425 micron should be 6 or within 6, and this is specified in IS 2720 part 5. So next let us see what is the construction operation involved in crusher run macadam. So first stage in construction operation is preparation of subgrade. So any ruts, deformation or soft yielding places which occur in the subbase or subgrade shall be corrected and compacted to required density before aggregate base course is placed thereon. So here also it is same. So before laying crusher run macadam, the subbase or subgrade has to be prepared. So if there is any ruts or if there is any deformation in the subgrade, it has to be rectified and it has to be repaired. Suppose some points are soft and these soft points are yielding, then such places has to be identified and it has to be corrected by using some coarse aggregate and by compacting the coarse aggregate before laying of this crusher run macadam. And the second stage of construction is spreading, watering, mixing and compaction. The aggregate shall be uniformly deposited on the approved subgrade by means of hauling vehicle with or without spreading device. Water shall be applied prior to and during all blading and processing operations to moisten the material sufficiently to prevent segregation of fine and coarse particles. Water shall be applied in sufficient amount during construction to assist in compaction. The aggregates used in the construction should be uniformly deposited on the approved subgrade, and the deposition of aggregates will be done using a vehicle, and the vehicle may consist or it may not consist the spreading device. And here the water is applied prior to the spreading of aggregate. So here the aggregates are bought from the quarry and it is dumped at one point, and there the water is sprinkled to the aggregate, and the aggregate which are sprinkled with water are then spreaded evenly throughout the pavement surface. And while spreading of the aggregate also, the water is sprinkled on the aggregates in order to prevent the segregation of coarse and fine aggregates. And the sprinkling of water also helps in compaction. So with more water content, the compaction of the aggregates become easier, and hence the water is applied in sufficient amount during the compaction, which makes the compaction easier and the material will become denser with the compaction. So compaction, it shall commence immediately after the spreading operation. If the thickness of single compacted layer does not exceed 100 mm, a smooth wheel roller of 80 to 100 kN weight may be used. For compacted single layer up to 200 mm, the compaction shall be done with the help of vibratory roller of minimum static weight of 80 to 100 kN or equivalent capacity roller. The speed of the roller shall not exceed 5 km per hour. So here also the compaction is done in the same way as it is done in previous method, that is in wet mix macadam. So here if the thickness of a single compacted layer is less than 100 mm, a roller of weight 80 to 100 kN is used for the compaction. If the compacted layer is more than 100 mm, or if it is between 100 to 200 mm thickness, and if the layer is a single layer, then the compaction is done by using a vibratory roller, and the minimum static weight of the vibratory roller should be between 80 to 100 kN. And here also it should be noted that the speed of the roller should not exceed 5 km per hour. So when the speed of a roller is maintained at 5 km per hour, then all the surface of a pavement will get a even compaction. So after compaction, The next stage is surface finish and quality control of work. The surface finish of construction shall conform to the requirement of clause 902. Control on the quality of materials and works shall be exercised by the engineer in accordance with the section 900. So here also the surface finish and quality control of work specification is same as previous two granular payments. So the surface finish should conform for the requirements of clause 902 of MORTH specification, and the quality control of materials which is used in the construction of a pavement should conform with respect to section 900 of MORTH specification or as per the specification of engineer. Then arrangement of traffic is the next stage, and after that measurements for payment. So arrangement of traffic measurements for payment. So these stages are same as previous two methods. So here, apart from the specification of materials and the specification of different layers construction, a care should be taken for a safety plan. So here we have to take care for a safety of environment and for the safety of vehicles. So when we consider the environmental safety, the nearby streams, watercourses, lake reservoirs shall be protected from contamination by the soil erosion from the area exposed during excavation by constructing temporary berms, dikes, sediment basins, etc. So, by the use of this temporary mulches, seedings, or other controlling devices, we can prevent the soil entering into the water body from soil erosion. And after the next safety, what we need to consider is safety for vehicle. So here the vehicle tracks shall be kept moist to prevent flying of dust particles with the vehicle movement. So apart from the specification of IS or IRC or MORTH specification, we should also consider the safety plans in the construction of a pavement. So now let us see what is a primer coat. Primer coat over granular base. So this work shall consist of application of a single coat of low viscosity liquid bituminous material to a porous granular surface preparatory to the superimposition of bituminous treatment or mix. The prime coat, it is a typically it is a low viscosity bitumen application over a granular base. So the application of this prime coat is to prepare the surface for laying of a bituminous mix or for the laying of asphalt mixture. A prime coat has several important functions, like the prime coat loosens the material particles on the surface of the base, and the prime coat also hardens the surface of the base. It waterproofs the surface of the base by plugging capillaries or interconnecting voids, provides adhesion or bond between the base and the asphalt mixture or bituminous mixture, and the bituminous emulsions are used for as a prime coat, and this emulsion will be having a slow setting emulsion properties because of a cationic nature. So what are the materials used in prime coat? So primer. The choice of a bituminous primer shall depend upon the porosity characteristics of the surface to be primed as classified in IRC 16. So these are surfaces of low porosity such as wet mix macadam and waterborne macadam. Second one, surface of medium porosity such as cement stabilized soil base. Third one is surface of high porosity such as gravel base. Here the selection of material for a bituminous primer depends upon the porosity characteristics of the surface which has to be coated. So here the surface will be having low viscosity, or the surface will be having, the surface will be having a low porosity, the surface will be having medium to high porosity. So depending upon this porosity characteristics, the material of primer is decided, because this primer should penetrate the first few millimeters of a layer very quickly. So here in this picture you can see the layer is being treated with a prime coat. So primer viscosity. The type and viscosity of the primer shall compile with the requirements of IS 8887 as sampled and tested for bituminous primer in accordance with these standards. Guidance on viscosity and rate of spray is given in the table. So in this table you can see the type of surface and what should be the viscosity of a material. So in the first column it is type of surface. Here we have low porosity, medium porosity and high porosity. So here the viscosity of primer at 60 degree. For low viscosity, for low porosity, the viscosity of primer should be between 60 to 30 to 60 at a temperature of 60 degrees Celsius, and for medium porosity, the viscosity should be between 70 to 140. For high porosity, the viscosity should be between 250 to 500. Similarly, the quantity of liquid bituminous material per 10 square meter is also given in the table. So for low porosity material, or for the low porosity pavement surface, the quantity of liquid bituminous material should be between 6 to 9. For medium porosity it should be between 9 to 12, and for high porosity it should be between 12 to 15. So here the prime coat will not succeed if the emulsion is of a viscosity that does not correspond to the gravel or has too high breaking speed. So choice of primer. The primer shall be bitumen emulsion of type and grade as specified in the contractor as directed by the engineer. So the choice of primer depends upon different engineers, and it also depends upon the importance of a project. So here what the contractor will do is he will select a primer depending upon the contract what he has assigned, or he will select a primer depending upon the engineer. So the engineer will suggest which type of primer has to be used in the construction depending upon the importance of the project. So weather and seasonal limitation. So what are the limitations for the use of this bituminous primer? So bituminous primer shall not be applied to a wet surface or during a dust storm, or when the weather is foggy, rainy or windy, or when the temperature in the shade is less than 10 degrees Celsius. Surfaces which are to receive emulsion primer should be damp, but no free or standing water shall be present. So there are some criteria for spraying of a primer. So the spraying of primer depends upon weather, and there is some limitations for that. So the primer should not be applied on wet surfaces. The primer should not be applied during the dust storm, and during the fog we should not apply the primer. During the rainy season or during the rain, the primer should not be sprayed. So the ideal time or the ideal condition for spraying of primer is the primer should be damp, but it should be free, and it should not consist of any standing water. So it is the ideal condition for spraying of a primer. So next is a construction. So how it is constructed. So equipment. The primer distributor shall be a self-propelled or towed bitumen pressure sprayer equipment for spraying the material uniformly at specified rate and temperature, and spraying of small and areas inaccessible to the distribu- distributor or in narrow strip shall be sprayed with a pressure and sprayer or as directed by the engineer. So the equipment used in the spraying of primer is a sprayer with high pressure. So here the sprayer which is used for spraying of this primer should uniformly spray the primer throughout the pavement, and with variation of the temperature there should not be any changes in the sprayer, but the spray of primer should be uniform even at worst condition, and the hand spraying of small areas, or we can also use ant sprayers for the inaccessible areas, and this depends upon the engineer. So the engineer should suggest when we should use the ant sprayer or when we should use a pressure sprayer for spraying of a primer. So the next stage is preparation of road surface. So immediately prior to applying the primer, the surface shall be carefully swept clean of dust and loose particles, care being taken not to disturb the interlock aggregate. So before spraying of the primer, the surface has to be cleaned. The surface has to be removed from dust particles. The surface has to be kept clean from other impurities, and the cleaning process should take place in such a way that we should not disturb the interlock aggregate. So care should be taken while cleaning the surface. So after cleaning or after preparation of the road surface, the next stage is application of bituminous primer. The viscosity and rate of application of the primer shall be as specified in the contract, or as determined by site trials carried out as directed by the engineer. The method for application of the primer will depend on type of equipment to be used, size of nozzle, pressure at the spray bar, and speed of forward movement. So in the third stage, that is in the application of bituminous primer, the viscosity and rate of application of primer depends upon the contract which is signed by the contractor. So the government engineer who has prepared the construction report will specify a type of primer that has to be applied for the pavement surface. So depending upon that, the contractor will apply the primer, and the method of application of primer will depend on type of equipment used, size of nozzles, pressure at the spray, and it also depends upon the engineer's decision. And the next stage is curing of primer and opening to traffic. A primed surface shall be allowed to cure for 24 hours or such other period as is found to be necessary to allow all the volatiles to evaporate before any subsequent surface treatment or mix is laid. Any unabsorbed primer shall first be bloated with an application of sand using minimum quantity possible. So before allowing the traffic on the pavement, we should cure the primer. So curing of primer should be done at least for 24 hours. So after curing the primer for 24 hours and before allowing the vehicles on the constructed pavement, the engineer should check the pavement surface. So if there is any unabsorbed primer, he should rectify that, and for that place he should use a fine aggregate. So the quantity of fine aggregate used in the place of unabsorbed primer should be minimum, and a primed surface shall not be open to traffic other than that necessary to lay the next course. A very thin layer of clean sand may be applied to the surface of the primer to prevent the primer picking up under the wheels of paver and the trucks delivering bituminous material to the paver. So after curing of primer for the 24 hours of duration, the next stages are quality control of the work, arrangement of traffic, and measurement for the payment. Measurement for the payment. So this stages is same as previous two methods.